Hey folks, welcome back. Trigonometry, angles and ratios, lesson 2. Trig ratios for angles from 0 to 360 degrees. So this lesson is going to review some ideas about our trig ratios, SOHCAHTOA, sine, cosine, and tangent. It's going to review how we use Pythagorean theorem, and it's going to combine that idea with reference and rotation angles that we learned in lesson 1. Okay. So first of all, Pythagorean theorem. Traditional formula for the Pythagorean theorem is c squared is equal to a squared plus b squared. That's what you are used to seeing. That's what you should know. Okay. In trigonometry, we use x, y, and r instead of a, b, and c. That's because we can plot the point x, y, and r we talk about being the radius of the circle, which you'll see in a quick second. So the point pxy lies on the terminal arm of angle theta. And the distance from the origin to point P is r, which is the radius of the circle formed by the rotation. So if we have this point, xy, it's going to land here. This would be our rotation angle. Okay. If we kept rotating, we would end up getting a circle. So that's why we call this r. This is the radius of a circle. Okay. So there's going to be a little bit in here, a little bit in this lesson that we're going to kind of skim and bypass. I do that because it tends to confuse students. But we'll come back to those same kind of ideas or those values in these investigations in a later lesson. So it's all right. So normally our right angle triangle kind of might kind of look like this. Right angle, where this is A and this is B and this is C. But now we're going to use X instead of A, we're going to use Y instead of B, and we're going to use R instead of C. So it's the same idea, we're just using different variables. Okay, so example 1, sketch the rotation angle in standard position and calculate the exact distance from the origin to the given point. Where appropriate, write your answer in simplest mixed radical form. Always, always, always. Okay, so that will make sense as we hit there. So this is called the distance from the point P to the origin. This distance here. This would be our origin. This would be our point, xy. Okay, so we need to figure out that coordinate, that distance, and we can calculate that distance using Pythagorean theorem. And remember, we can use our Pythagorean theorem if we had this distance to calculate one of the legs if we had the other one, right? Just so you're aware, we are going to be doing that as well. So first we're going to start with a coordinate grid. Negative 5, 12. Negative 5, 12 might be up here somewhere. Totally not to scale. It's going to be out here somewhere. Negative 5, 12. They want us to figure out the distance from the origin in simplest mixed radical form. So really, this is our triangle that we have. Here's our one side, here's our other side. This makes our 90-degree angle. This distance being negative 5, this distance being 12, we need to find r. So we start with our formula. R squared is equal to x squared plus y squared. Substitute in x and y. Negative 5 squared plus 12 squared is equal to 25 plus 144, which is 169. So r squared is equal to 169. To find r, we take the square root of both sides. R would be the square root of 169, and in this case, this is a perfect square, 13. So we don't have to worry about our mixed radical stuff. That looks like a B. I'm going to make that look like a 13. So R is 13. In example B, point -2, -6 on the terminal arm of angle A. So again, we draw our coordinate grid. plot our point, -2, -6. Somewhere down here maybe, -2, -6. And we draw our angle. And we need to calculate values. So I know that this is going to form my right angle triangle here. This is going to be -2. This would be -6. We need to find r. So we're going to go r squared is equal to x squared plus y squared, which is -2 squared plus -6 squared, which is 4 plus 36, which is 40. So r squared is equal to 40, but now we take the square root of both sides, and we get r is equal to the square root of 40. Now that is not perfect, so I need to simplify that. So somewhere I'm going to do my radical simplification work. Draw your tree, 2, 20, 2, 10, 2, 5. There's my group of 2. That 2 comes out. This 2 times 5 stays on the inside, 10. So this is actually 2 square root 10. So you're going to need to refresh your memory on how to simplify radicals. Okay, takes us to the end of example 1. Over the page, quick review of our trig ratios, sine, cosine, and tangent ratios. Remember that sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, have to remember that. And that comes from our labeled triangle. If this is angle theta, this is the side opposite, this is the adjacent, and the hypotenuse is always opposite to the 90 degree. Okay. Our primary trig ratios. And of course, remember your acronym SOHCAHTOA. Now with the angle stuff that we work with, because we're using x, y, and r, we can change our formulas, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Sorry about that, got interrupted by my kid. Where were we? Oh, we were talking about our primary trig ratios in relation to x, y, and r. Okay, so in terms of x, y, and r, if theta is our angle, this side is my opposite side, this side is my adjacent side, and of course, opposite to my 90 is always my hypotenuse. So I can replace hypotenuse with r, I can replace adjacent with x, and I can replace opposite with y. So we get new trig ratios. Sine would be opposite would be y over r, cosine would be x over r, and sine would be y over x. You need to know these new ratios, okay? An easy way to remember them, 7 yellow rabbits. 7 yellow rabbits says that sine is y over r. Well, if sine is y over r, then cosine is x over r, the other one, and tangent is y over x. But whatever is going to make you remember or help you remember, you need to remember those. So now let's use those. Okay? Example 3. The point 15.8 lies on the terminal arm of an angle theta as shown. Calculate r and hence determine the exact values of the primary trig ratios. Okay? So here we know that it's 15.8. So this point here is 15.8, which means this distance is 15, this distance is 8. We need to find r, and then we need to do our trig ratios. So over here, I'm going to go r, I'm going to change colors, I'm not liking the red. R squared is equal to x squared plus y squared, 15 squared plus 8 squared. I don't know why I put a comma there. I don't know why I put a 0 there. 225 plus 64. R squared is equal to 289. 289, that's an 8. Square root both sides. R is equal to, I think that's a perfect square, 17. Nice. So that's nice and easy for our first one, which is good. And then we need to fill in our primary trig ratios. So I start with my formula. Sine of theta is equal to y over r, which is equal to, my y value is 8 over 17. Cosine theta is equal to x over r, which is 15 over 17. And tangent theta is equal to y over x, which is 8 over 15. Quick review of how to substitute into your trig ratios. Now, of course, if you remember, now that we have this ratio, I can use the inverse function of sine to figure out my angle, or this ratio, inverse function of cosine, to figure out the angle, or inverse function of tangent to find the angle. So that's the next step, is now we can determine these angles. Okay. Now, instead of doing the investigations on the next page, I'm going to back up to example number 2 again, and I'm going to talk about what these ratios do in these other 3 quadrants, quadrants 2, 3, and 4. Okay, so this is technically this is quadrant 1. What happens, or what changes when we move to quadrant 2? Okay, which means over here, I'm now going to go and put a point. So from here, I'm going to mirror image that point over here. There's my angle. I still have a coordinate point, except in this case, it's going to be negative x, positive y. And I'm still going to have my right angle triangle. It's going to be formed here and here. This would be negative x. This would be positive y. If I did the Pythagorean theorem or whatever, I would still get a value for r. And then I could substitute into my sine, cosine, and tangent ratios. So over here, I would say that sine theta, which is y over r, is still going to be just y over r. My cosine, though, cos theta, which is x over r, this time it's negative x over r. X is negative. Tangent theta, ugly, theta is y over negative x. So see what happens in quadrant 2? Our cosine value turns to negative, and our tangent value turns to negative. And we can continue that pattern on. We can continue that pattern on for our other 2 quadrants. So now let's mirror image our point down here. We're going to have this angle. We're going to have this y value. This x value is still negative, but this one becomes negative y because it goes down, right? And r. R is always positive, by the way. Always, always, always. So yes, r is always positive. So in quadrant 3, if I did the same thing, sine of theta would be y over r, but now it's negative y over r. Cosine of theta is equal to negative x over r. And tangent of theta is negative y over negative x, but that's actually just y over x. Turns out to be positive, right? Negative over a negative is positive. And then if I went to quadrant 4, and mirror imaged my point out here, this point here, back over here, sorry, let's go back over here for a quick second. This would be negative x, negative y. This point in quadrant 4 is going to be positive x, negative y. We still have our triangle. Here's our negative y. Here's our positive x. We go to our trig functions. In quadrant 4, sine theta is equal to negative y over positive r. Cosine theta is equal to positive x over r. Tangent theta is negative y over r. So you can see that the signs of the ratios change from quadrant 1 through to 2, 3, and 4 based on the values of x and y, depending on where they are. Okay, so that's the whole idea of what you're supposed to be able to gain from doing these investigations, part 1 through to part 4. Like I said, this tends to confuse some students if we do these investigations. So I just kind of gave you the preamble. Okay, so if we go to this nice summary table on the bottom of this page, bottom of 172, just before that though, here's what you're supposed to have gained. Observations. The trig ratios for angles between 90 and 360 are either the trig ratios of the reference angle or the negative trig ratios of the reference angle. So it's either positive or negative versions. The signs of the trig ratios depend on the quadrant, whether x and y are positive or negative. Okay, that's all you needed to gain through those investigations. This is a nice little summary table of all of that. In quadrant 1, draw the rotation angle theta in standard position and complete the table. Repeat for quadrants 2, 3, and 4. In quadrant 1, we note that both y and x are positive and r is always positive. So y is positive, r is positive. Positive over a positive gives me a positive. So in quadrant 1, sine is positive. In quadrant 2, x over r, x is positive, r is positive. This is positive over positive, that's a positive. Tangent is y over x, which is positive over a positive, overall positive. So in quadrant 1, all 3 trig ratios are positive. Okay, this is the bottom line. This is what we're trying to determine. In quadrant 1, all of these are positive. If we flip to quadrant 2, we still know that this is y over r, this is x over r, this is y over x, except that y in this case in quadrant 2 is still positive, r is positive, overall positive. X though, this is a negative x value, negative over a positive, overall negative, and tangent, positive over negative, overall negative. So in quadrant 2, only sine is positive. Okay. In quadrant 1, they're all positive. In quadrant 3, this is a negative x, this is a negative y. So when I fill this in, y over r, x over r, y over x, this is negative over a positive, which is negative. This is a negative over a positive, which is negative. This is a negative over a negative, which is positive. Tangent is the only one that's positive in quadrant 3. And lastly, quadrant 4. This is x, no, this is not x over r, this is y over r. This is x over r, this is y over x. Here we have a positive x value, but a negative y value. So it's negative over a positive, overall negative, positive over a positive, overall positive, negative over a positive, overall negative. Cosine is the only one that's positive in quadrant 4. Those are the keys. Those are the 4 key things that we need to gain from that investigation. In quadrant 1, all trig ratios are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. These statements in question C, so over the page, these statements in question C, just help us to kind of summarize that. So you might try and remember these 6 points. I can figure them out, but it's not because I know them. It's because I know a different rule. Okay? So sine ratios have positive values in quadrants 1 and 2. Cosine ratios have positive values in quadrants 2 and 4. 2 and 4, is that right? Yeah, 2 and 4. Cosine's positive, 2 and 4. No. Cosine ratios, positive values in 1 and 4. 1 and 4. Tangent ratios have positive values in 1 and 3. Sine ratios have negative values. See, this one I have troubles with. Sine ratios have negative values in 3 and 4. 3 and 4. 1, 2, 3, 4. Well, the others, right? If it's 1 and 2 positive, then 3 and 4 is negative. Cosine values have negative values in quadrants. Can't be 1 or 4, so it's got to be 2 and 3. And tangent would be 2 and 4. But there's a much easier way to remember all of these. That rule is called the cast rule. Okay? The cast rule tells you where the trig ratios are positive. If they're not positive, then they have to be negative, correct? So the cast rule, or some people like to use this one, add sugar to coffee, and there's a reason. So the cast rule is defined as this: C A S T. And it's called the cast rule because it spells a word, right? Except you have to remember that you start in quadrant 4 when writing out your cast rule. C A S T. Okay. The reason some people use add sugar to coffee is because it goes with the same numbers. Add same numbers as the coordinate grid numbers. Add is quadrant 1. Sugar 2. 2, 3. Coffee 4. Right? So add sugar to coffee. Whichever one you want to use, it makes no difference to me. I personally use the cast rule. Okay? It's a nice word to remember, cast rule instead of 4 words, right? So I use the cast rule. And we can use this rule to very quickly determine the sign of some particular trig ratios. We can also do that, well, with this example 4, we're also going to do it with example 5, okay? So example 4, determine without using technology whether a given trig ratio is positive or negative. So all you have to do is think about, okay, well, whoops, don't draw random lines anywhere. I have to think about, well, where does 340 degrees terminate? Starts here, it's going to terminate somewhere over here. It's going to terminate somewhere in quadrant 4. So I go to my cast rule, C A S T. In my cast rule, this says that in quadrant 4, which is where we are in quadrant 4, cosine is the only one that's positive. So sine 340 degrees has to be negative. Okay? And you just continually do that each time. Well, I might be able to draw grids everywhere. Tangent 227 degrees. Here's my coordinate grid. Tangent's going to start here and at 227 somewhere in here. This is quadrant 3. In quadrant 3, C A S T, my tangent is positive, so this is going to be positive. Sine 88 degrees is in quadrant 1. Boom, out here somewhere. That's quadrant 1. All CAST, all trig ratios in quadrant 1 are positive. This will be positive. In question D, here's my grid. My angle is going to be somewhere in quadrant 3, somewhere 235 degrees. In quadrant 3, C, A, S, T. Tangent is positive, so this is going to be negative. I would like you to try E and F. I'm going to pause my video because I need a break for a second. So take a second, try E and F, see if you can figure out positive or negative values. Pause the video if you need to. Hopefully you paused the video and you took a stab at this. Question E, 308 degrees is going to give me an angle somewhere in quadrant 4. In quadrant 4, CAST, cosine is positive. This will be positive. And finally, question F, tangent 123 degrees. 123 degrees is going to finish in quadrant 2 somewhere. CAST, sine is the only one that's positive, so tangent has to be negative. Now, of course, when we're given numbers, we can also start to incorporate reference angles and stuff. So if this is 123 degrees, then this reference angle would be 57, right? So that's what we're going to do with example 5, is we're going to start including reference angles. Okay, let's flip the page. Example number 5. Oh, no, let's not flip the page. Hold on a moment. Trig ratios of an angle in terms of their reference angle. So normally with all of these questions, we always ask about the reference angle. If it's specified rotation angle, then of course you need to do some stuff. Otherwise, if a question doesn't specify, then we're always talking about the reference angle, okay? And this is the process that we work through. So first, we determine the sign, whether it's going to be positive or negative. We determine the angle, the reference angle itself, based on the information that we're given, and then we combine 1 and 2 together. Okay, so here's an example. To write the cosine, I think that's something we have a negative. Yeah, to write cosine of 260 degrees, the cosine of an acute angle using the above procedure. So first of all, 260 degrees. In my head, I'm thinking, well, 260 degrees is going to finish in quadrant 3 somewhere. CAST. I know that it's going to have to be negative. Okay, it's going to have to be negative. So if this is 260 degrees, what is this reference angle? This reference angle is going to be 80 degrees. So cosine of 260 degrees is equal to cosine of 80 degrees, because that's the reference angle, and it has to be negative because that's the quadrant it's in. Okay, so that's what we need to be able to determine. Over the page, rewrite the same trig functions of an acute angle. So sine of 140 degrees. So I'm going to here, sine of 140 degrees. So I first determine my sine, positive or negative sign, by the way. There's my angle. That's in quadrant 2, CAST. Sine is going to be positive, so I know my answer is going to be positive. Then I think, well, if this is 140 degrees, then my reference angle has to be 40. So sine of 140 is also going to be equal to the sine of 40 degrees. Okay? That's the beauty of reference angles, and that's what we're going to want. Okay? Sometimes it helps if you sketch this, whoops, not this. If you just sketch this grid somewhere and just keep referring to it, CAST. Okay, just like SOHCAHTOA. Question B, tangent of 323 degrees. Here's my grid. 323 is going to finish down here in quadrant 3 somewhere. That's my rotation angle. So CAST, tangent is positive. This one's going to be positive. Oh, no, sorry. 323. I read that totally wrong. 323 should end over here somewhere. I read 2 something. 323 should end over here somewhere. So that's in quadrant 4. In quadrant 4, C, cosine is positive, so this is going to be negative. So I know my answer is going to be negative. Tangent. What's the reference angle? Well, if this is 323, this last leftover bit is 360. Take away 323, which is what, 37? 37 degrees. So the tangent of 323 degrees is equal to the negative tangent of 37 degrees. And you could test this on your calculator. Punch in tangent 323. Punch in -1 times tangent 37, and you'll get exactly the same answer. Question C, cosine 165. So cosine 165, that angle is going to be over here somewhere, CAST. Sine is positive, so that means cosine is going to be negative. If this is 165, then my reference angle is 25. No, 15. 15. So negative 15. Negative cosine 15 degrees. Question D. Pause the video. Try some of these out if you want. Here's question D. Hopefully you paused your video and tried it. Sine 287 is going to end here somewhere in quadrant 4, CAST, whereas cosine is positive. So that means it's going to be negative sine, and this reference angle would be 360 minus 287, which is equal to 52. No, 73, sorry, 73. 52 is my next one. Question E, cosine 308. 308 degrees ends up over here somewhere. So that's my rotation angle, 308. It's quadrant 4, cosine is positive. So this is going to be equal to cosine. My reference angle, 360, take away 308. Is that 52? 52 degrees. Okay. Tangent 199. Draw my angle. 199 is going to be right here somewhere. That's 180, so this has got to be 199. CAST, tangent is positive, so that's going to be positive. And 199, 180, 180. No, sorry. 199 minus 180 is equal to 19. 19 degrees. So that's my reference angle. Okay, so we're always talking about the reference angle. Now, there's a nice pattern if you're interested in memorizing or knowing equations and stuff. If you can remember these, that gives you exactly the same thing. I don't use these. I don't know them off by heart. So asking me questions about these, probably not going to help too much. I know how to use the cast rule and apply the cast rule, okay, or the add sugar to coffee rule. Either or, whichever one works best for you. I wouldn't necessarily try to remember all of these formula. They're not necessary. You're not going to need them again. It's really not going to help you. Okay, that brings us to the end of lesson 2. Checking Stellantis and the sideboard to see what questions need to be completed. And we will see you next time.